Hello everyone, hope you're all doing good. I thought before starting the subject Big Data Analytics, we will have a small discussion or an introduction about what is Big Data Analytics. And after that, we will move on to the syllabus where we'll try to cover the topics that is given in the syllabus, as well as we will try to touch up few more other things what are related to Big Data Analytics, which is not specified in the syllabus. Also, we'll discuss about few of the tools that are already available. Last week I had shared about a course on Google Analytics and hope you're all doing that particular course, which is free of cost. So moving on, first we should know what is big data. So for big data there are multiple definitions that we can find it from the textbooks, websites or articles. So one such definition is that is it refers to a dataset whose size is beyond the ability of a typical database software tool, something like Excel. And these tools usually it capture the data, store the data, manage it, and it analyzes it. So similar type of another definition is this also tells about the same, but it is put in a different wordings. Refers to that is the data that is so large, fast and complex that is it is difficult or impossible to process using the traditional method. The same definition but put in a different words. And also for this big data, as I already told, this analytics has been around from a long time, and usually what it does is it accesses the data, stores the large amount of data basically for analytics purpose. Another definition is it also talks about something same, but here we can see that big data there are can be a huge amount of data which can be structured, can be unstructured, as well as it can be semi-structured also, and that overwhelms the business on a day-to-day basis. That is, all this data what it comes is been analyzed by the business. The business can be any type of business. It can be education business, it can be retail business, or it can be commerce business, it can be of anything, but most of the times the data is structured or it can be semi-structured or unstructured. We also generate the data from multiple devices that we use, from our smartphone, from the website, that is from the social media website which we use, Facebook, the chatting platform which we use, WhatsApp, Twitter. So all those generates a huge amount of data which is too much to be stored, and what we are going to do with that is what matters. So it is not how much data is there, but it is what this organization or what these businesses or companies are going to do with this data which they are going to store. So that is what is about big data. So this is where it talks about data analytics, that is the data which we extract from all this particular businesses or different platforms comes in terms of terabytes or petabytes. It can be anything, and even it can be more than that also. It is. So what we are going to do with this data by using the cost effective or reliable methods are the important ones. So this is where the big data analytics becomes necessary. We will have a brief look on what are the different units which we use for storing the data, that is to measure the data. We have heard about bit, bytes, kilobytes, megabytes, gigabytes, terabytes. So beyond that we have petabyte, which is 1 followed by 15 zeros. We have exabyte, which is 1 followed by 18 zeros. We have zettabyte, which is 1 followed by 21 zeros, and we have yottabyte, which is 1 followed by 24 zeros. So these are in terms of bytes. You can see the numerical values which are mentioned there, and petabyte is denoted by using PB, exabyte is EB, zettabyte is ZB, and yottabyte is YB. So when we talk about these things, we should also see what do you mean by data, and in a particular day how much data we are going to use. So this image which you see is actually the analysis or the particular data which has been generated in 2019. So if you see from this particular point in 2019, on a particular day, if you mention, there is almost 3.9 billion people who use emails. These many number of people generate almost 294 billions of email per day. It is expected that by 2020 we'll be having 306 billion emails to be sent on each day, and by 2021 it will rise to 320 billions of email. Also, you can see that on a day, on an average, we have around 500 million tweets that is being sent every day. And Facebook also generates almost 4 PB. PB is nothing but petabyte of data, where 350 million photos are getting uploaded or created. Also, 100 million hours of video watch time has also been increased. And also the messages what have been sent by WhatsApp is almost 65 billion, where we have almost 2 billion minutes of voice and video calls are also made along with that. Also, the cars or the vehicles which are connected to the smart devices also generate a huge amount of data. So you can see almost 4 TB of data is being generated per day by an autonomous, it can be an autonomous car also. Coming here, you can see that it is being predicted that by 2025 we'll be having 463 exabytes of data which is going to get generated on a single day. And on Instagram also it is not less, we have 95 million photos and videos are getting shared on Instagram. The wearable devices which we use, the smart devices, the activity trackers, the smart watches, so those also generate, it has been expecting that 28 petabytes of data will be generated by 2020. This particular image shows about the comparison of a 60-minute, it is called as an internet minute, that is 60 seconds. If you browse on internet, what and all things you'll be doing. So this is what happens in an internet minute. So on the left side you can see what is it is telling about on 2018 what was happening, and the right side tells about in 2019 what is happening. So just to have a small comparison, you can see 2018 Google had 3.7 million searches or queries which happened in a single minute. Same thing if you compare in 2019, it is 3. It has risen to 3.8 million queries. Facebook had 9,73,000 logins which was happening in a minute, which has rise to 1 million logins in 2019. So similarly, if you watch, you can see that different apps or different platforms which had a huge rise when it is compared to 2018 to 2019, and in 2020 also it is booming up. Now we'll have a small example of how this data analytics works. So I taken an example of we going to buy a pair of dress. So usually what happens is we go to a particular shop, it can be a mall or it can be a sales outlet. We go there, we take trials with multiple pairs of dresses, and finally we'll fix one thing and you come to the cash counter. So when you come to cash counter, usually ask, most of the time we ask for some offer. Sometimes they only will prefer saying that we have a particular offer. So just imagine that the cash counter, the person who is there is offering you 10% off on the purchase, and by signing up to a store's credit card. It means that you have to take a credit card which is owned by the shop along with some other banking partners. So they give you 10% off, 10% save on this particular card. That is when next time and whenever you use this card, you'll be having a 10% off. So it has been told that 99.9% of the people will be saying no. Why? Because usually when you are going to take a credit card, people will be having a second thought, because we are going to get into more troubles, we may tend to have more purchases. But just imagine we have this data, whatever purchases you have done in the store backend, in the store's particular memory or the system. So what they do is this, just scan through all your previous purchases, and by seeing those things, if they're able to offer you 50% off on a similar purchase, for example, it has checked your database and it has found out that you are a regular customer of that particular outlet. So by seeing your past purchases, they are going to offer you 50% off. So which one do you prefer? So obviously people will go for the 50% off. So this is one more place where data analytics come into picture. So there were huge amount of data by multiple customers daily, day-to-day basis. People come and purchase items from that particular shop. From all those details, the system has gone back and checked only your particular purchase details, and after that it has come up with an offer like this. So this is one example where big data analytics is been implemented. One more example is about insurance companies, which we usually see, that is whenever the financial year is going to end, you can see that a lot of insurance companies, insurance offers will be getting as emails, messages, and other ways also. So they, most of the time, how they do is they'll be having one particular product or a particular policy which they try to give it to all the people. But if you take the help of data analytics, the companies can go and check the previous data of the customers, and they'll be able to check which age group is preferring which and all more type of policies, and which policy is apt for your particular age. It can be a teenager. For teenager, which type of policies are better? For a middle-aged person, which type of policies are better? For an elderly person, which type of policies are better? And for which policies the more claims are happening, and for which policies the company is having more benefit as well as the customers are having more benefit. So by seeing all this data, if they are able to specify a particular policy according to your age as well as your previous policy histories also. For example, some people will be having a habit of claiming multiple times, maybe due to their health issues or due to accidents or some things. So if by referring all those things, if that data analytics software or the insurance companies, the system will be able to prefer your particular policy, it would be always better. So this is one more example where analytics come into picture. In the next class, we will discuss more about big data. Thank you.